Okay, let's proceed to the theoretical aspect of 2025 WAEC mathematics solution. Okay, let's start with the first question. Given that the universal set equals to x such that 1 is less than x less than 20, where x is an integer, and p equals to x such that x is a multiple of 3, and q equals to x such that x is a prime number, where p and q are subsets of the universal set, find a p intersection q prime, b p prime union q, c p union q prime. Okay, now please pay attention. We are given that the universal set equals to x such that 1 is less than x less than 20. Okay, now we are given another set p. Set p equals to x as well, x such that x is a multiples of 3. X is a multiples of 3. Okay, then we are given another set q. For set q we have x such that x is a prime number. Okay, prime number, where p and q are subsets of u of the universal set. Find, okay, we are asked to find p intersection q prime. Then the second question there is p intersection q, okay, p prime intersection q. Then the third question is p union q prime. Okay, these are the three questions that we are given under this first question. Now please pay attention. Before you can solve any of these questions, you first have to write out the elements in the universal set, the elements in the set p, and the elements in the set q. Do you understand? Okay, let's start with the elements in the universal set. You must know how to interpret what you have in this bracket. The universal set, listen. The universal set is, listen, 1 is less than x. 1 is less than x means that x is greater than 1. Are you getting it? So, and 1 is less than x simply means that x is greater than 1. Is that not it? And x is less than 20. X is less than 20 simply means that 20 is greater than x. So that means that the values of the universal set ranges from 2 to 19. You understand? Because we are given that 1 is less than x. That means that x is not equal to 1. So x starts from 2. Okay, I'm going to have the universal set which contains all these elements: 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. Okay, these are the elements inside the universal set. Do you understand? Okay, now look at the other set. P equals to x such that x is a multiples of 3. X is a multiple of 3 simply means that, okay, for set P now I'm going to have 3 times 1, that is 3, because x is a multiple of 3. Are you getting what I'm trying to say? So 3 times 1 is 3, 3 times 2 6, 3 times 3 9, 3 times 4 that is 12, 3 times 5 that is 15, 3 times 6 that is 18, 3 times 7, 3 times 6 that is 18, 3 times 7 that is 21. But listen to me carefully, we cannot put 21, and the reason is simply because you know that we are given in the question that p and q are subsets of subset of the universal set. Are you getting it? So we cannot include 21 because even the universal set does not reach 21. Are you getting it? So the elements that is present in set P are 3, 6, 9, 12, 15, and 18. Are you getting it? Okay, now for set Q, we have Q equals to x such that x is a prime number. What are prime number? Prime number are numbers that have only 2 factors, which is 1 and itself. Are you getting it? Now, between the range of 2 to 19, what are the prime number that we have? Okay, so I'm going to have Q. The element that is present in Q will include 2. 2 is a prime number, and the reason is simply because 2 is divisible by itself and 1 without remainder. Are you getting what I'm trying to say? 3 is also a prime number. 3 is a prime number because 3 is divisible by itself and 1 without remainder. If you divide 3 by any numbers, you are going to have a remainder. Are you getting it? For example, if you divide 3 by 2, you are going to have a remainder. Are you getting what I'm trying to say? So that means that we have 2, 3. What of 4? 4 is not a prime number, and the reason is simply because if you divide 4 by 2, you are not going to have any remainder. Are you getting it? So we cannot put 4. What of 5? 5 is also a prime number because 5 is divisible by itself and 1 without remainder. Are you getting it? So we're going to have 5 here. What of 6? 6 cannot be regarded as 8. 7 is a prime number. 8 is not a prime number. What of 9? 9 is not a prime number. 10 is not a prime number. 11 is a prime number. We put it there. Then what of 12? 12 is not a prime number because 12 is divisible by 2. It is divisible by 4. It is divisible by 3, even without remainder. It is divisible by 6. Are you getting it? So now 11 is a prime number. 12 is not a prime number. What of 13? 13 is also a prime number. So put it there, 13. What of 14? 14 is not a prime number. 15 is not a prime number. 16 is not a prime number. 17 is a prime number. So you put it there. You put 17. What of 18? 18 is not a prime number because it is divisible by 3. Are you getting it? 18 divided by 3 will give us 6. Okay, so we cannot regard 18 as a prime number. Don't forget the definition of a prime number. They are numbers that is only divisible by itself and 1 without remainder. Are you getting it? So 18 cannot be regarded as a prime number. What of 19? 19 is a prime number. So we put it there, 19. So you can see that if you look at, please pay attention. If you look at the set P and Q, you will discover that all the elements that is present in set P are also included in the universal set. All the elements that are present in set Q are also present in the universal set. That is what is meant by PQ being the subset of the universal set. Are you getting it? So now, having since we have written the elements that is present in both set P and set Q, now we can now go back to the question. We are asked to find P intersection Q prime. Okay, before we can find P intersection Q prime, we need to determine Q prime. You understand? You see, this sign that you see here is known as prime. Are you getting it? And the meaning is simply the elements that are present in the universal set that are not present in set Q. Do you understand? Listen to me carefully. Q prime is this. They are the elements that are present in the universal set but are not present in set Q. Are you getting it? So that means that if I want to get Q prime for the element that are present there is that I'm going to do it like this. 2 is present in set Q, so I'm not going to include it. 3 is present in the universal set, but is also present in set Q. I'm not going to include it. 4 is present in the universal set. It is not present in set Q, so I'm going to put 4. Listen to me carefully. Q prime are the elements that are present in the universal set but are not in the set Q. Do you understand? Okay, so I need Q prime. You will discover that 2 is present in the universal set, but it is not present in set Q. 2 is present in the universal set, but it is also present in set Q. So I'm not going to put it there because the element that I need as Q prime, they are the set of values that are present in the universal set but are not present in set Q. Do you understand? So 2 cannot be included because it is also found in the universal set. 3 cannot be included because it's also present here. 4 can be included. 4 is part because 4 is present in the universal set and it is not part of set Q. Do you understand? 5 cannot be included. 6, we can put 6 because 6 is not part. What of 7? We cannot put 7. We have 8. We have 9. We have 10. 11. We are not going to include it. We have 12. We have 14. Then we have 15. We have 16. 17. No. 18. We have 18 as well. Okay. So Q prime, these are the elements that are present in the universal set but are not part of set Q. You can check. 4 is present here, not present here. 6 present here, is not present here. 8 and others like that. Okay, so these are the Q prime. Now, having gotten Q prime, we can now look for P intersection Q prime. Don't forget, I'm still on question A. Okay, P intersection Q prime. P intersection Q prime. That will be. Do you know the meaning of intersection? Intersection simply means the element that are common to both sets. Are you getting it? Intersection of a set means the elements that are common to both set P and set Q. So what are the elements that are the elements that are common to both set P and set Q prime? Do you understand? These elements that are in set Q prime are these. Are you getting it? So I need the element that is common to set P and set Q prime. Look at this. P is here and we have Q prime here. P intersection Q prime will be elements that are common to this set and this set. Do you understand? Okay, let us start. 3 is not common. 6 is common. So you put 6. Okay, 6. What of 9? 9 is common. So you put 9. Okay, because you see 9 is present here, 9 is also present here. What of 12? 12 is common, so you put 12. What of 15? 15 is common, so you put 15. What of 18? 18 is common to both sets, so you put 18. So P intersection Q prime is 6, 9, 12, 15, and 18. Do you understand? Intersection deals with the elements common to two sets. You understand? So you will realize that we cannot find P intersection Q prime without looking for Q prime. That is why I take time to explain what is meant by Q prime. Are you getting what I'm trying to say? And you know, in some textbook or in some resources, you will discover that they didn't use prime. They use complement. You understand? It doesn't matter. Okay? It still means the same thing. So whether complement or prime, you are still going to arrive at the same answer. Just know that anytime you have maybe an apostrophe or this kind of sign on the top of any set, all you have to do is that just look for the elements that are present in the universal set that are not present in the set that I'm looking for. You see, you will discover that we cannot find P intersection Q prime without looking for Q prime. You understand? So that is why I first look for Q prime. You see, this sign that I call prime is also known as complement. You understand? But whether complement or prime, this also means the same thing. I get what I'm trying to say. Okay, so we are done with the first one. Let us proceed to the second one. P prime intersection Q, or P complement intersection Q. Okay. P complement intersection Q. P complement intersection Q. Now, listen to me. We cannot find P complement intersection Q without looking for P complement. So, the first step is that you have to look for P complement. So, let us find P complement. P complement will be the elements that are present in the universal set but are not in set P. Do you understand? Okay? So, these are the elements in set P. What are the elements that are present in the universal set that are not present in set P? We have 2. We have 4. Are you getting it? 2 is present here, it is not present here. 4 is present here, it is not present here. 3 is present here and it's also present here. So I'm not going to include 3. Do you understand? Okay, 4 is present here, it's not present here. What of 5? 5 is present, but it's not present in set P. What of 6? 6 is present in universal set, but it's not present in, it's also present in set P, so I'm not going to include it. What of 7? We are going to include 7. 8, 10, 11, 13, 14, 16, then we have 17, 19. These are P prime or P complement. Are you getting it? So having gotten P complement, we cannot proceed to find P complement intersection Q complement. Okay, P complement, let me just put it here. P complement intersection Q. Oh, sorry. P complement intersection Q. Okay, so we're going to have this P complement. Are you getting it? Please pay attention. It's simple. Okay, this is P complement. The intersection of these elements of the elements that are present here and Q, that is what we are looking for. And I told you that intersection refers to the elements that are common to both sets. Are you getting it? So what are the elements that are common to this set and this? You can see that 2 is common, so I'm going to include 2. 2 is part of it. 2 is common here, and it's also common here. What of 3? 3 is not common, so I'm not going to put it. What of 4? 4 is not common. 5 is common. After 5, what of 7? 7 is common to them. What of 8? 8 is not common. What of 10? 10 is not present here. It is present here. We are not going to include it. What of 11? 11 is present in both sets, so I'm going to have 11. What of 13? 13 is present in both sets, so I'm going to have 13 as well. What of 17? 17 is present here, is not present here, so I'm not going to include it. 14 is present here, is not present here. I'm not going to include it. Okay. What of 16? 16 is not common. 17, oh, 17 is common. So let us put it 17. Okay. What of 19? 19 is also common. So P complement intersection Q are 2, 5, 7, 11, 13, 17, and 19. Okay. The next question under that question is this: P complement union Q. That is C. P complement union Q. Don't forget that I told you that this sign that you see here, which is complement, is also the same thing as prime. You understand? You can call it prime or complement. So now, for this, P complement is this. You understand? So we want to take the union of this, the element that is here, and the element of Q. Do you understand? Okay, the union simply means that writing all the elements that is present in this set and this set without a repetition. You understand? If we have an element that is present in both sets, we are going to take one. Are you getting what I'm trying to say? So let us proceed. P prime, we have 2. 2 is also present here, so we are going to have 2. Okay, we have 4. Okay, another one. We have 3. 3 comes before 4. You understand? We have 3, but 3 is not present here, so we are going to write it. Don't forget, listing out all the elements in both sets without repetition is what we call the union of a set. Are you getting it? Writing out the elements in both sets without repetition is what we call the union of a set. So whether the elements are common or not, we're going to list out all the elements, and eventually if the element that is present in both sets, if we have an element or a number that is present in both sets, we are going to take one. Do you understand? Okay, that is what we call the union of a set. Okay, so we have 3. After 3, we have 4 here, so let's include 4. After 4, do we have 5? Okay, 5 is present in Q, so 5 is also present here, so we are going to take 1. So 5. After 5, do we have 6? There is no 6. Okay, we have 7 in both sets, so we just put 7. Just put 1 7. We have 8 here, but 8 is not present here, so you put 8 as well. Okay, because union of a set simply means listing out all the elements that is present in both sets without a repetition. Okay, so this is 8 as well. After 8, what do we have? We have 10. Okay, put 10. We have 11. We have 13. We have 14. We have 16. Okay, 16. We have 17. We have 19. Okay, so this is P complement union Q. So we are done with this question. We are done with this. We are done with this. Okay, let's look at the fourth one. Okay, the fourth one says we should find P union Q complement. P union Q complement. Okay, now look at this. Before we can find P union Q complement, we first have to find P union Q. You understand? And I told you that the union of a set refers to the listing. You have to list out all the elements that is present in both sets without repetition. You understand? So to get P union Q complement, the first thing is that we have to first find P union Q. Okay? So let's get P union Q. That is the P union Q. Okay, this is P and this is Q. So we have to list out all the elements that is present in both sets without repetition, right? So let's start with 2. We're going to have 2 here, followed by 3. Okay, then followed by 6. Okay, followed by 5 because we have 5 here. 5, followed by 6. We have 7. After 7, we have 9. Then after 9, we have 11. Then 12. 13, 14 is not present in any. So let's put 15. After 15, there is no 16. Okay, put 17 because 17 is present here. After 17, we have 18, then 19. Okay, so this is P union Q. Okay, now let us find P union Q complement. P union Q complement. P union Q complement. Okay, you can see that the complement is outside the bracket. You understand? So therefore you have to pay attention to the parentheses. Okay, so now this is P union Q. P union Q complement refers to the elements that are inside the universal set that is not present in the union of P and Q. Do you understand? Like the elements that are present in the universal set but are not present in the union of P and Q. So what are those elements? 2 is present, so we are not going to include 2. 3 is present, we are not going to include 3. 4 is not present here, so we are going to put 4. 4, okay. 5 is present, we are not going to include 5. 6 is present. 7, okay. 8 is not present, so we are going to put 8, okay. Do you understand what I'm doing? Listen to me carefully. P union Q is this. P union Q complement refers to the elements that are present in the universal set. The universal set is the superset of all the sets that we have here. Are you getting it? So the elements that are present in the universal set that are not present in set Q is known as P, and that are not present in the union of P and Q is known as P union Q complement. Do you understand? And if you check very well, you will discover that 4 is not present here. So we are going to include 4. 4 is not present here, but 4 is present in the universal set. Okay, so we are going to put 4. After 4, we have 8. Okay, after 8, 9, 10 is not present, so we put 10. After that, 11 is present, 12, 13. Okay, we put 14, 16, 16. After 16, okay, these are all the elements that we have in the P union Q complement. 4, 8, 10, 14, and 16. Okay, if you check those elements in the universal set, you will discover that they are present in the universal set, but they are not present in the union of P and Q. That is what we mean by complement. Okay, the complement of a set refers to the elements that are present in the universal set but are not present in the given set. Are you getting it? That is the complement of that set. Okay, so we are done with the first question. So I'm very sure you understand the solution now. If you don't understand, you can call my attention. Okay, so let us proceed to the next question. The product of the ages of Adu and Sanko is 9 less than Akofa's age. If Tanko is 4 years older than Adu and Akofa's age is 6 times Tanko age, find Akofa's age. Okay, this question is coming from a topic known as word problem. Are you getting it? So the first step is that you have to interpret the question. Yeah, are you getting it? Like you have to interpret the question into equation. So let's proceed. The product of the ages of Adu and Tanko is 9 less than Akofa's age. Let Adu's age be A. Okay, let Adu's age, that is question 2. Let Adu's age, let it be A, and let Tanko age, let Tanko age be T, and let Akofa's age, we represent it as letter, okay? Let Akofa's age, let it be K, you understand? Okay, now from the first statement, please pay attention. From the first statement, the product of the ages of Adu and Tanko, that is A multiplied by T. Are you getting it? The product of the ages of Adu and Tanko is 9 less than Akofa's age. That is, the product of the ages of these two is equals to Akofa's age minus 9. Do you get it? So that's it. That's the interpretation of the first statement. Okay? The first statement is here. The product of the ages of Adu and Tanko is 9 less than Akofa's age. Now, if Tanko is 4 years older than Adu, and Akofa's age is 6 times Tanko age. Tanko, the second statement, Tanko is 4 years older than Adu, and Adu's age is what? A. So Tanko's age is equals to A plus 4. Do you understand? Okay.
To watch the complete class, kindly click on the link in the description of this video or the comment section. Okay. See you in the next class.